Welcome to the world of big questions and tiny discoveries, where curiosity never sleeps. This is The Sleepy Scientist, where we stroll together among the stars, listen to the slow rhythm of the universe, and pose questions that sometimes only dreams can answer. Tonight, we will quietly step into one of the deepest mysteries, something seemingly simple, yet makes both science and philosophy pause and ponder. If you want to complete this journey, don't forget to hit follow and subscribe to the channel so that every night we can open the window to the universe together and let our imagination soar. We have stepped through the first door of curiosity, and now let us slowly tiptoe into one of the deepest mysteries of the universe, what nothing truly is. If before you lies only an empty jar, start from there. That empty jar is not just a void of matter. It is a vivid painting where air molecules dance like invisible popcorn kernels. Oxygen, nitrogen, a bit of carbon dioxide, along with the lingering scent of cinnamon from last week, all combine to form an energetic nothing. Even if you suck out all the air, creating an apparently perfect vacuum, you still cannot reach absolute nothingness. Quantum fields exist everywhere, oscillating and rippling, even when matter is completely gone, reminding us that emptiness in the universe is never truly silent. If we broaden our perspective, nothing is not just inside a jar, but also exists in the vastness of space. Imagine a vacuum region between galaxies, seemingly empty, yet in reality it is a boiling sea of energy, where virtual particles appear and disappear, dancing to a quantum rhythm that the naked eye cannot see. Even when standing in the quietest dark corner of the universe, you still cannot find absolute nothingness. The absence of matter does not mean the absence of energy, and from here, the question begins to expand into a more abstract level. Does nothing truly exist in the way we imagine it? Beyond matter, we step into the realm of empty space, yet full of potential. According to modern physics, even a perfect vacuum not only oscillates, it contains possibilities that have not yet occurred, virtual particles that exist for a moment like miraculous beats in the universe. This is where modern science touches philosophy. Nothingness is not just absence, but also possibility. It is like a white canvas that is not merely empty, but ready to take any form if a force acts upon it. Even quantum physicists must admit that even nothing is part of the structure of the universe. It is not exactly an object, but neither is it absolute void. It is a state of latent energy. This leads us to a deeper insight. Nothing is a relative concept, always dependent on observation. When you look at an empty jar, you see emptiness, but on a microscopic level, it is filled with particles, forces, and energy. When looking at the vast universe, the gaps between galaxies also contain quantum energy, and in a philosophical context, nothingness becomes even more abstract, an absence of everything, including space and time. If both space and time are removed, you confront a state that language cannot describe. No up or down, no before or after, no matter or energy, only pure emptiness. And here the question of nothing begins to astonish us. Can it exist in the way we understand it, or is it merely an idea, an abstract form of imagination? The deeper we dig, the more we realize that science and philosophy together explore the magical aspects of nothingness. Contrary to ordinary intuition, nothing is not always simple. It exists in many forms, from a jar containing air to a seething quantum vacuum, from silent space to a timeless state. Each form of nothingness opens a new layer of meaning, forcing us to ask ourselves, what are we truly facing? Is it matter, energy, or just a concept? And within these layers of metaphor, we begin to understand a subtle truth. Existence and emptiness are not two opposing extremes, but two sides of the same coin. To illustrate this, let us return to the example of the jar. When observed at a microscopic level, you see a world of dancing energy and molecules, where nothingness seems to melt into potential life. When expanded to a cosmic scale, nothingness still exists, but in a way we can only speculate. Quantum fields, vacuum energy, quantum fluctuations all form a vivid picture of what seems empty. And in a philosophical context, absolute absence becomes a concept that language cannot grasp, an abstract domain of thought that only the mind can touch. It is in these contemplations that we see that the question of nothing is not meaningless. On the contrary, it opens a door to a profound understanding of the universe, energy, and the nature of existence. The most wonderful thing is that, although this question is abstract and sometimes counterintuitive, it still evokes natural curiosity, a very human trait. We always want to seek, understand, and explore. And it is in this journey that nothing becomes a strange but magical starting point, leading us from the molecular particles in an empty jar to quantum fields, from the space between galaxies to reflections on timelessness. It teaches us that even emptiness has a story, and through that story, we learn to appreciate everything that exists. So, when you look at a void, remember that emptiness is not always nothingness. It is opportunity, it is potential, it is a state of the universe waiting to be explored. And if you feel yourself drifting through these ideas, take a deep breath, relax, and let your imagination guide you. Nothing, or at least the way we understand it, is the first step to understanding everything. If you try to imagine the universe at the beginning, do not picture it as a firework exploding into pre existing space. In fact, space and time did not yet exist. Everything we call length, width, or moments had not been created. Instead of exploding into a void, it was that very void that was created from the first moment. Space expanded, time flipped its switch, and with maximal energy, the universe began to write its story. We stand before a moment in which before does not exist, after is not yet defined, and all usual laws of causality become blurred. In the smallest fraction of the first second, the universe was a scorching, dense, and chaotic plasma, where fundamental particles moved at nearly the speed of light. Even atoms, protons, or neutrons had not yet formed. All matter existed only as quarks and leptons, the most basic building blocks of matter. This tremendous heat transformed the plasma into a brilliant mixture of pure energy, but it was the expansion, a continuous stretching of space, that led to gradual cooling, allowing quarks to combine, protons and neutrons to form, and a few minutes later, the first simple nuclei appeared, mostly hydrogen with a small amount of helium. A few 100,000 years later, just a blink in cosmic time, electrons began to stabilize in orbits around nuclei. For the first time, neutral atoms formed. This moment marked the transparency of the universe. Light was no longer scattered by free particles, but freely spread everywhere. That moment created the cosmic microwave background, CMB, a frozen snapshot in time, preserving the echo of creation, a delicate replica of the early universe that we can still observe today. Small fluctuations in the CMB are clues about the first structures, the seeds of galaxies, stars, planets, and eventually, life. The miracle is that, although everything began from a state of chaos and maximal energy, the universe quickly created order. Why? Because the Big Bang was not merely a simple expansion. It was the starting point of physical laws, the moment when entropy began to increase and where primordial order was established. This leads to an equally fascinating question. Why did the universe begin in a low entropy state, primed for complexity? It seems that everything was carefully prepared, from the first atoms to distant galaxies, allowing life to emerge billions of years later. But if the Big Bang marks the beginning of space and time, what happened before it? This question takes us to the edge of thought. Before time existed, the concepts of before or after are completely meaningless. No flow, no events, just a timeless, spaceless state, a kind of nothingness that the human imagination can only vaguely conceive. It is like asking about the north of the North Pole. You cannot go further north because the pole is the limit. Similarly, the concept of time reaches its boundary at the Big Bang. Time never existed before. It began with the universe. To illustrate this, we can think of a clock that has never been manufactured. Before it existed, no moments were measured, no mechanism functioned. When the clock first turns on, it begins marking time. Similarly, the Big Bang is the switch that turned on time, space, and energy, initiating everything that follows. The cause of this switch lies beyond ordinary causal logic, because causality depends on the flow of time. Some physicists suggest this is a boundary condition. The universe appeared because the physical laws already existed, requiring no temporal cause. This becomes even stranger when we realize that time and space are inherently linked according to general relativity. They are not separate. Space-time is a gigantic elastic sheet, bending and stretching according to energy and mass. Gravity is not just a force of attraction, but a manifestation of the curvature of space-time itself. This structure also has a starting point, and the Big Bang is that point. There is no surface to explode into, no backdrop to expand upon. The expansion is the creation of space itself. Another interesting aspect is the term Big Bang. The phrase was coined as a joke by astronomer Fred Hoyle, who supported the steady state model and was skeptical of a universe with a beginning. By calling the opposing idea the Big Bang, he merely wanted to mock a concept he considered absurd. Ironically, evidence increasingly supported the Big Bang theory, and the name, initially a joke, became a symbol of the universe's beginning. There was no actual explosion, only the expansion of space and time, gentle yet powerful, giving rise to everything. So, when we look at the universe today, every star, every galaxy, every light we observe is the result of a chain of events that began with the Big Bang, not through fire or explosion, but through shape and rhythm, through the breath of the universe. Every present moment, including the moment you are reading these lines, is part of a grand history spanning 13.8 billion years. And the astonishing thing is that, despite our extensive knowledge, the core questions about the cause, meaning, and origin before the Big Bang remain a mystery, inviting curiosity to continue its adventure. In that light, the Big Bang becomes not only a physical theory, but also a philosophical story, reminding us of the fragility, wonder, and absoluteness of beginnings. It teaches that every moment, from breath, heartbeat to the light of stars, is part of a flow greater than ourselves, a flow that began from a point where there was nothing at all. And in the silence of the question before that, we find the beauty of nothingness, the beauty of potential, and the beauty of existence itself. If we continue to contemplate quantum vacuum, we see that it is not as silent as initially imagined. Even when looking at an empty void without particles or light, the vacuum itself is a boiling sea of energy. Quantum fluctuations are not just abstract theory, they are the invisible heartbeat from which matter, energy, and even the universe can emerge. In the briefest moment, energy can rise and fall, creating virtual particles that appear and vanish, like fleeting ripples on a still water surface. These fluctuations are tiny but real, and strong enough to produce profound consequences. Imagine them as waves on an invisible ocean, but not of water, rather of primordial energy spread throughout potential space. Each quantum field, from electrons, quarks, to photons, and the Higgs boson, is like a separate ocean within this vast sea. When a field fluctuates strongly enough in the right way, it can create an actual particle, a piece of matter present in space-time. And if these fluctuations resonate in an extremely rare manner, theory suggests an extraordinary event can occur, the birth of a new universe. Theoretical physicists such as Alexander Vilenkin and Andrei Linde have proposed that the universe may have originated from the quantum vacuum. This vacuum is not the philosophical nothingness, where nothing exists at all, but a physical state capable of fluctuation, a quantum vacuum filled with latent energy. In this state, there is no three-dimensional space or flow of time. Everything lies beyond the ordinary concept of existence. Yet, thanks to the uncertainty rules of quantum mechanics, energy can temporarily burst at a single point, initiating a universe, not by an external agent, but by the potentialities already inherent within the vacuum itself. Importantly, even with such a beginning, the new universe does not appear in the sense of an explosion as we imagine. No fragments are thrown out, no tremendous roar, no swirling clouds of dust. Instead, there is an extremely rapid expansion, a process in which space and time themselves stretch and spread, creating all that would later become galaxies, stars, planets, and atoms. It is a quiet yet powerful birth, the first breath of an entirely new reality. This expansion is not random. The initial quantum fluctuations, though tiny, are amplified as the universe expands, creating small wrinkles in matter density. These wrinkles become the seeds of large structures later, galaxies, star clusters, and ultimately ourselves. A tiny flicker in the quantum vacuum can determine the shape of the universe, the distribution of galaxies, and even the ratio of hydrogen to helium in space. This beginning is both random and delicate, like planting a seed in the soil and watching it grow into a giant tree, with no one able to precisely predict the shape of its leaves or the direction of its roots. So if the quantum vacuum is always fluctuating, could universes appear multiple times? Some physicists believe this is entirely possible. Each rare, strong quantum fluctuation could generate a new universe, an independent branch with its own space and time. This opens the concept of a multiverse, countless universes, each born from a quantum vacuum, free to evolve according to its own physical laws. We may be living in one branch among infinite possibilities, yet from inside, our experience of the universe is unique. Astonishingly, these seemingly far-fetched ideas are still grounded in actual observations. The cosmic microwave background, CMB, the redshift of galaxies, and the ratios of light elements all provide clues about the initial expansion. The small traces in modern data are actually imprints of primordial quantum fluctuations, the original ripples that determine today's cosmic structure. Thus, the quantum vacuum is not a distant hypothesis, but a real part of the story of the beginning. Furthermore, this concept carries a profound philosophical dimension. If the universe can emerge from quantum nothingness, existence does not require a cause in the conventional sense. Not because matter or an external agent created it, but because of the spontaneous potential of quantum fields. This changes the way we think about cause and effect, about time and space. The beginning does not require a traditional cause. The universe is self-existent, arising from a foundation whose very nature already contains the capacity to generate everything. Finally, all of this leads to an understanding that is both scientific and philosophical. The universe, with all its stars, black holes, atoms, and even our consciousness, may originate from a small quantum fluctuation in nothingness. Everything, from Beethoven to the banana bread on the table this morning, is the result of a beginning both delicate and extraordinary. The universe does not require a massive explosion. It only needs a moment of potential, a pulse of vacuum fluctuation, and from that, all existence ignited, spread, and blossomed. So, when we look at the night sky and wonder about the origin of everything, we can imagine that each star, each galaxy, and ourselves are children of the quantum vacuum. From that seemingly empty stillness, life and consciousness emerged, proving that even from nothing, everything can arise. And in that silence, we witness the extraordinary beauty of the beginning, a beginning not of explosion, but of breath, not of fragments, but of the entire universe. When we look up at the night sky, whether with the naked eye or through modern telescopes, a marvel appears. Everything seems to be receding, galaxies gradually drifting apart, light from billions of years ago still traveling toward us, carrying the story of the early universe. This is evidence of the universe's expansion, but if we delve deeper, we discover a subtler layer of meaning. This expansion did not occur uniformly from any arbitrary beginning, but is the result of an extreme phase called cosmic inflation. In the very first moments, less than a billionth of a second, space expanded faster than the speed of light, stretching from a tiny potential point into a vast region, laying the foundation for all future galaxies. This was not a violent explosion, but a silent, quiet expansion, yet so powerful that the shape of the universe afterward reflects this very phase. Inflation not only explains why the universe today appears uniform and flat, but also reveals a profound connection with quantum fluctuations. During the inflationary moment, tiny fluctuations in the quantum vacuum, invisible potential ripples, were amplified into wrinkles in matter density. These small wrinkles became the seeds of large structures, galaxies, galaxy clusters, and vast galactic filaments. Thus, a minuscule event, almost imperceptible in the moment before inflation, became the key to forming the entire cosmic structure. A quantum fluctuation, invisible and fleeting, now exists on a cosmic scale, determining the trajectory of stars, planets, and even us. Observing this reality allows us to understand that in the quantum world, the tiny and the grand are directly connected. Fleeting virtual particles, temporary fluctuations that seem meaningless, can pave the way for the entire universe to emerge from a potential state. It is hard to imagine that a quantum vibration, a whisper of the vacuum, could become the foundation for everything from quarks to distant galaxies. And when we question the origin of these fluctuations, a sense of scientific humility fills us. We do not know for certain. We only know that they exist, and they are powerful enough to create everything. Another strange but fascinating aspect of inflation is its symmetry with time. As the universe expands, the laws of physics continue to operate as they do everywhere else. But if quantum mechanics is time-symmetric, could there exist a mirror universe expanding in the opposite direction from ours? Some theoretical physicists believe it is possible. If so, we are not witnessing a single quantum beginning, but a network of possibilities where one universe forms while a reflected universe simultaneously emerges, both born from the same quantum potential. This vision, though fantastical, reminds us that truth does not always conform to intuition. It may exceed our imagination, yet still fully obey the laws of nature. Cosmic inflation also carries a profound philosophical lesson. The universe does not require an external cause in the traditional sense. It can spontaneously arise from the potentials inherent in the quantum vacuum. An event, if we may call it that, occurs without fragments, without an external wall or stage. It only requires quantum mechanics and fluctuations within a potential state. Everything then begins to develop, spread, and form matter, energy, space, and time. This beginning is not violent, yet extraordinarily effective. A silent, delicate mechanism, both simple and wondrous. When observing the traces of the inflationary phase, such as the cosmic microwave background CMB, we find compelling physical evidence. The first quantum fluctuations left imprints in every direction of space. Each ripple in the CMB data is a reminder that the universe grew from a tiny seed, and that everything, including humans, is the product of quantum vibrations. This brings a sense of both awe and humility. Existence, in its broadest sense, may begin from the smallest, most fleeting possibility and radiate outward into everything. Finally, the idea of quantum inflation opens a door to unexplored possibilities. If the universe can spontaneously arise from a quantum fluctuation, then perhaps more than one universe exists. There may be countless possibilities, each becoming a separate universe, with different physical laws, different forms of existence. We live in one universe, but it may be just a small branch in a vast network of possibilities. And it all begins with a tiny, nearly imperceptible quantum fluctuation, yet powerful enough to give rise to all space and time. In that absolute silence, in the invisible moment when all possibilities coexist simultaneously, we realize that the beginning of the universe was not a violent explosion, but a whisper of potential, a silent vibration in the quantum vacuum, paving the way for all matter, energy, and consciousness to emerge. From that, everything from tiny quarks to enormous galaxies, from dark energy to human intelligence, is the consequence of a brief but miraculous moment when the quantum void empowered reality. And in that moment, we learn that even silence can create everything, that nothingness is not an end, but the beginning of the greatest and most wondrous adventure, our universe. When we imagine the universe not merely as galaxies and planets, but as a gigantic foam of many tiny universes, a wondrous and incredible idea emerges. Each spatial bubble is an independent universe, capable of existing and evolving according to its own laws. In this picture, our universe is just one among countless bubbles born from exponential expansion, each bubble emerging from tiny fluctuations in the quantum field, and each carrying unique imprints of its moment of origin. We have long been accustomed to viewing everything from a single perspective, imagining that a big bang or a quantum burst created our universe. But now the universe is no longer a singular entity. It becomes part of a vast, complex system where possibilities coexist everywhere. This is the marvel revealed by eternal inflation. From a fleeting quantum event, an entire network of universes can be born, spreading across an infinite sea of space, where every possibility is tested. But the wonder is not only in the infinite number. Each tiny universe in that foam, each bubble, carries profound imprints of how inflation operates. When a region of space where the quantum field remains at high energy expands, it creates more space for other quantum fluctuations, thereby giving rise to new bubbles, like a domino effect between possibility and reality. Our universe, where inflation ended earlier, became a calm region where matter and energy were released as radiation and particles, allowing galaxies, stars, and planets to form. Meanwhile, other regions continue to expand, giving birth to many new universes beyond our observation. From a tiny quantum vibration, an entire network of reality spontaneously emerges, stretching infinitely. Yet each branch carries its own distinct imprint, like independent notes that together form the grand symphony of the cosmos. This raises an astonishing philosophical question. If there are countless universes, why are we in this one? The answer lies in quantum natural selection, bubbles in which the laws of physics do not support the formation of complex matter. or do not allow stable particles to exist, will not have galaxies, stars, or life. They may exist, but there will be no witness to observe them. Our universe, with its delicately balanced conditions, indicates that among infinite possibilities, some bubbles are favorable for life to persist, and we are fortunate to have arisen in one of them. The silence of other universes, never touched by us, becomes the foundation for reflecting on the fragile yet wondrous reality in which we live. Moreover, eternal inflation does not merely produce separate bubbles but forms a deep structure where each universe can be seen as a particle in a vast quantum sea. As a universe expands, it not only grows in space but also amplifies the initial quantum fluctuations. The smallest fluctuations, seemingly insignificant at first glance, become the nuclei of galaxies, stellar storms, and later complex matter structures. This suggests a subtle connection between the microscopic and the cosmic scale. Quantum fluctuations in the earliest moment, fleeting and elusive, determine the shape, density, and history of an entire universe. It is precisely in this interplay between the small and the great that we perceive a profound philosophical message. From what seems negligible, everything can arise. This discovery leads to a feeling both overwhelming and humbling. We live in a universe whose entire history, structure, and possibilities for existence were written from nearly invisible quantum fluctuations. Every life, every planet, every speck of dust in the Milky Way is the result of a chain of events that, if even a single factor were different, the universe would not exist as it does today. This highlights the reverence we should hold for the cosmos. It is not a mundane product of randomness, but the result of subtle and powerful possibilities, where every particle of energy and every quantum ripple contributes to the emergence of reality. At the same time, the concept of the multiverse opens limitless possibilities for imagination and scientific exploration. Not confined to our universe alone, theoretical science now faces a broader reality. There may be countless physical laws, forms of matter, and conditions appearing simultaneously in other universes. This not only changes our understanding of physics, but also expands our philosophical vision. The void is no longer merely an empty space. It becomes an ocean of infinite potential where anything can occur, where every universe has a chance to emerge from delicate quantum ripples. Clues from observations of the cosmic microwave background radiation and inflationary models help us better understand the early history of the universe, yet they remain only fragments of the larger picture. Each observation, each small fluctuation in ancient light, is a reminder that our universe originated from a subtle, nearly silent process where inflation and quantum fluctuations together mapped out reality. And it is precisely that silence, combined with the potential energy in the inflating field, that created the space for everything to happen, from the first quark to the first star, and ultimately to our own consciousness. Indeed, when imagining our entire universe as a tiny bubble within the infinite foam of eternal inflation, we see ourselves as both small and special. We are witnesses to an endless process, a chain of possibilities giving rise to reality from fragile quantum ripples. Every moment of existence, every scientific discovery reflects the initial possibilities that spread, multiplied, and integrated into spacetime. From a fleeting quantum fluctuation, an entire multiverse spontaneously arises, spreading infinitely, containing not only untold stories, but also the opportunities for life and consciousness to emerge. If eternal inflation opens up the infinite possibilities of universe bubbles, then the Big Bounce model or cyclic quantum cosmology suggests a different vision, where the universe does not begin from a singular point, but is reborn through cycles of contraction and expansion. In this picture, our universe is not the only child just emerging from a moment of nothingness, but rather the next segment in a continuous flow of time where previous universes existed, experienced birth and death, and left faint traces in the quantum structure of space. This idea opens a profound perspective. The universe has no absolute beginning. Instead, it exists as a cyclical process where bounces replace singular points and continuous cycles of birth and contraction create an eternal history, vast yet subtle enough to elude intuitive grasp. Imagine the universe as a sequence of expanding bubbles, but this time, the old bubbles do not entirely disappear. They influence the new ones. In the Big Bounce, The contraction of the previous universe generates quantum pressure, a force resisting collapse, so that space is not crushed into infinity but bounces back, opening a new phase of expansion. This is not an absolute beginning, but a relative starting point, where quantum conditions keep the universe from total annihilation. Upon closer inspection, the Big Bounce demonstrates the continuity and self-regulating capacity of space, a sophisticated mechanism that the laws of physics had never revealed before. Astonishingly, in this model, each bounce can leave subtle traces in the next universe. Quantum fluctuations from the prior universe, though faint, can form variations in the cosmic microwave background or in the large-scale structure of space. These fluctuations could be the fingerprints left behind, allowing scientists today with telescopes and sensitive detectors to seek evidence of previous universes. If found, this would open a completely new chapter in cosmology. Our history is not a singular starting point, but part of a long chain of cycles of existence and rebirth. Each big bounce also suggests a plausible solution to the problem of the universe's smoothness and flatness. In the standard model, inflation stretches space to flatten any irregularities. But in cyclic quantum cosmology, the contraction phase before the bounce can naturally create uniformity, so that the universe expanding afterward is already smooth and nearly perfect. This delivers a profound philosophical message. Smoothness does not require a separate miracle, but is the result of an eternal quantum process, where the universe self-adjusts and balances, like water finding its lowest level, or wind flowing across sand forming smooth curves. Moreover, the Big Bounce model harmonizes marvelously with discoveries about the multiverse. If each bounce creates a new cycle, then space and time become the foundation for the continuous branching of possibilities. Uh, One bounce could produce a universe nearly identical to ours, while another bounce might give rise to a universe with slightly different physical laws: stronger gravity, lighter particles, atoms decaying rapidly, or a universe with a different number of spatial dimensions. In this view, the existence of our universe, with finely tuned physical constants that allow life, is no longer a unique miracle. It is the inevitable consequence of an eternal trial process, where all possibilities are tested, and some bubbles happen to be suitable for life and consciousness to arise. This discovery also offers a new perspective on the concept of nothingness. In the Big Bounce model, there is no absolute moment of nothingness, no completely empty state before the universe appears. Instead, there is always an ongoing process, a space existing in the form of quantum energy, ready to bounce and expand. Nothingness, in this sense, has never existed in the absolute. It is a continuous potential state, where universes are always poised to emerge, conveying a profound meaning. Something always exists, whether we are aware of it or not. The Big Bounce also provides a subtle metaphor for regeneration and cycles in nature. Like a river flowing back and forth, or a heartbeat pulsing continuously in a living body, the universe undergoes cycles of contraction and expansion, where each bounce is a rebirth, creating new opportunities for structure, matter, and life. This is a profound idea, both scientific and philosophical. The universe is not a singular event, but a continuous process, where each moment results from previous moments and opens possibilities for subsequent ones. From the human perspective, these ideas are both provocative and uplifting. They remind us that the universe is not a solitary beginning in nothingness, but a continuous flow of time, space, and possibility. We do not merely live in a universe. We exist in an eternal process where birth, contraction, and rebirth are ordinary. And it is within this cycle that we find humility, wonder, and a sense of connection to a reality far greater than any imagination. And that is the marvel of the Big Bounce. It not only explains how the universe can avoid a singularity, but also opens a theoretical framework harmonious with the multiverse, with natural smoothness, with a novel concept of nothingness, and with the infinite potential of time. It reminds us that every moment, every particle of matter, and every consciousness exists as the result of an eternal chain of events, where space and time rotate, and life emerges as a subtle trace within the infinite sea of possibilities. If the Big Bounce suggests a cyclical history of the universe, then brain cosmology takes us even further, beyond the familiar dimensions and into a multidimensional context, where our universe is merely a thin membrane within a much larger expanse of space. In this picture, the concept of absolute nothingness vanishes. There is no longer a completely infinite void where everything arises from nothing. Instead, there exists a rich, multidimensional space where energy and matter can exist, transform, collide, and generate the events we call the Big Bang. Our universe becomes part of a far grander dance, a multidimensional choreography, where every collision, every vibration, and every bounce contributes to shaping the reality we experience. Imagine the brains, or multidimensional membranes, drifting through vast space, like thin sheets floating in an ocean. Our universe is one of them. And in the ekpyrotic model, the birth of the universe is not a popping forth from nothingness, but the result of a collision between two brains. When these membranes meet, energy trapped between the layers is released suddenly, producing an immense explosion, enough to generate matter, radiation, and the conditions necessary for the formation of galaxies, stars, planets, and ultimately life. In this context, the Big Bang is no longer the sole starting point. It is an event in a long sequence of collisions, part of an eternal dance. Interestingly, this model harmonizes marvelously with the idea of the big bounce cycles. While the quantum bounce emphasizes a rebound from a contracting state, brain collisions provide a multidimensional mechanism where the universe is born from trapped energy released in ways that our three-dimensional space cannot imagine. Each collision could create a completely different universe. Stronger or weaker gravity, lighter or heavier fundamental particles, slightly or entirely different physical laws, and even a different arrow of time. Among countless possibilities, our universe happens to possess the conditions suitable for life and consciousness to emerge, a testament to the anthropic principle. We are here to observe because we exist in an environment that allows us to exist. Brain cosmology not only expands spatial scales, but also extends the concept of time. If brains collide repeatedly, the history of the universe becomes a sequence of successive events, but not in a simple linear sense. Each collision, each bounce creates a new cycle, and these cycles may interact in complex ways, leaving subtle traces in the structure of space and the cosmic microwave background. Some models predict that gravitational waves, ripples in spacetime, could carry information from previous collisions, a subtle reminder that the universe always retains memory, even if we can only perceive a small part of it. Discovering extra dimensions in string theory is key to understanding brain cosmology. These spatial dimensions are compacted at extremely small scales, nearly invisible to our senses, yet they are the foundation for the existence of brains. Vibrations on these strings determine the types of fundamental particles we observe: electrons, photons, quarks, all manifestations of different vibration frequencies. In multidimensional space, each brain is an entity capable of containing energy, matter, and its own physical laws, ready to interact, collide, and give rise to a universe. This is a perspective both scientific and philosophical. The universe does not exist as a static unit, but as a dynamic, continuous, and creative process. From a philosophical standpoint, the brain model and string theory provide a new conception of nothingness and origin. The universe does not require an absolute first cause. It does not need a moment to arise from nothing. Instead, there is always a structure, a multidimensional space, an eternal potential of energy, ready to generate events that we experience as the Big Bang. This challenges intuition while offering reassurance. We are not alone in the universe, but part of a long-flowing current, an eternal history, where past, present, and future intertwine in a multidimensional dance. Each brain collision, each quantum bounce is an expression of infinite potential. Space and time become the stage for a continuous creative dance, where matter, energy, and information transform from one form to another. In this picture, entropy, the tendency toward disorder, is no longer an absolute threat, but can be diluted or reset during contraction, allowing subsequent cycles to unfold. The result is a rich cosmic history, where life, consciousness, and order are not miracles, but consequences of an eternal process. And finally, perhaps most beautifully, observing from within our own brain, everything appears as both familiar and mysterious. We walk upon a sheet of paper in a multidimensional ocean, experiencing time along its arrow, witnessing stars ignite and planets form, yet simultaneously understanding that around and beyond us lies a vaster universe, where other brains can collide, giving rise to new universes and continuing a creative dance that never ceases. In that moment of awareness, absolute nothingness disappears. Instead, there is a profound reassurance. Something always exists, eternal, vast, and full of potential. And our universe is merely a beat in that eternal dance, a thin sheet carrying the sparks of life, consciousness, and infinite possibility. If the early universe was not a sudden flash from nothingness, but a gently undulating panorama of space-time, then this raises a profound question. How can we, with our limited three-dimensional minds, grasp the full extent of that cosmic dance? The answer lies in combining physics with philosophy, where each physical theory opens new windows into abstract ideas of existence. In Hawking and Hartle's no-boundary model, the concept of before becomes meaningless. Time itself curves into a seamless, rounded geometry where every direction leads to existence without a fixed starting point. Just as standing at the South Pole renders south meaningless, time in the early universe exists not as a linear sequence of events, but as a curved surface, where every moment contains the potential of a self-contained, complete, and closed universe. Placed in the context of brain cosmology, this idea becomes much more vivid. If multidimensional brains can float in a space beyond familiar dimensions, collide, and generate energy to create new universes, then the no-boundary model becomes an abstract version of reality. Here, we see a deep interconnection. Energy, space, and time are all soft, interacting components where cosmic structures arise not from a singularity, but from a holistic quantum state, a timeless foundation where all possibilities exist simultaneously. Just as gravitational waves preserve the imprints of ancient cosmic collisions, the physical laws embedded in this structure record the memory of the entire history of the universe, but in a subtle, faint manner beyond our direct observation. Looking deep into the additional dimensions, where tiny strings vibrate to create material particles, we begin to realize that the universe is not a static machine, but a delicate dance where vibration frequencies determine the shape of reality. A low-frequency vibration produces an electron, a higher vibration produces a photon. And on a grand scale, colliding brains generate the Big Bang like a colossal musical chord, a sound invisible to the naked eye yet shaping everything around it. In this context, matter and energy become harmonies in an eternal symphony, where each collision, each vibration contributes to the creation of life, galaxies, and even our consciousness. But philosophy goes deeper than physics. Parmenides emphasized that absolute nothingness is impossible. One cannot conceive total absence without presupposing existence. His world was immutable, eternal, a singular entity where all change is an illusion. In contrast, Heraclitus emphasized constant flux, continuous change, where existence is a process, not a static state. Placing these two perspectives alongside modern physical theories, we see a marvelous fusion. The universe exists simultaneously as a closed entity, emerges through cycles of energy and collision, transforms through quantum vibrations, and preserves the traces of history without requiring a single starting point. Parmenides and Heraclitus' philosophies become a lens for understanding the no-boundary universe, both immutable and dynamic, both complete and expanding. When gazing at abstract mathematical models, such as the imaginary time used by Hawking and Hartle, we perceive a subtle metaphor. Instead of thinking of time as a straight line, imagine it as a curved surface, where all moments exist simultaneously and all possibilities are integrated. This is a mathematical method, but also a philosophical perspective. A beginning is not a fixed point, but a seamless whole, where every event, every vibration, and every possibility resides within a single structure. It reminds us that the universe requires no external agent to start. It self-generates from a holistic quantum state, and our existence is merely an expression within a larger dance. This also opens reflections on time, consciousness, and perception. If the universe is a brain floating in multidimensional space, we are ants crawling on that sheet, observing and experiencing time along its familiar arrow, yet unaware that elsewhere other brains may collide, generating other universes and creating parallel histories. Thus, understanding the universe is not only a scientific matter, but a philosophical one. We are seeing only a tiny portion of the infinite whole, and every model, every equation, is merely an attempt to connect the pieces we can observe with what exists beyond direct perception. Ultimately, All of this brings a wondrous sense of peace. The universe does not begin with a jolt, does not require a single cause, and is not constrained by absolute boundaries. It exists self-sufficient, complete, gently undulating, both finite and infinite. Every vibration, every collision, every bounce, from gravitational waves to fundamental string oscillations, contributes to the eternal dance of creation. In that vast stillness, we can recognize that nothingness never truly exists. Only existence, transformation, and an endless flow of energy, matter, and potential. And within that flow, we, small beings, become witnesses and co-participants in the grand symphony of the universe. As we continue along the philosophical path of nothingness, it is noteworthy how humans have always tried to shape what is inherently ungraspable. Parmenides and Heraclitus confronted two extremes. On one side, unchanging eternity. On the other, continuous flow, ever-changing light and fire. Thus, from the early observations of the ancient Greeks, the concept of absence, of non-space and non-time, began to seep into human consciousness. Heraclitus recognized that one cannot understand being without acknowledging non-being. This opens a spiritual void where emptiness is not merely a lack, but a structural part that allows everything else to exist. It is the underlying foundation where the emergence of life, matter, and consciousness becomes possible. As time passed, more practical thinkers such as Democritus and the atomists realized this idea in a more material sense. For them, the universe was composed of immutable atoms floating in empty space, a concept of nothingness that became useful, necessary for all motion. Empty space was not the enemy of existence, but the stage upon which the universe unfolded. They demonstrated that absence could be the foundation for presence, that not everything needed to be filled to realize order and form. And it was this idea, bold as it was, that paved the way for viewing the universe as a dynamic whole, where everything operates based on the relationship between being and emptiness. Plato, meanwhile, took the opposite approach, focusing on eternal forms, immaterial archetypes, where nothingness had no place. In his world, emptiness contained no truth, merely a pale illusion compared to perfect reality. Aristotle, Plato's student, continued this perspective, rejecting the void and believing that every region of the universe must be filled with something: air, ether, or some existing matter. This viewpoint dominated over 1,000 years of Western philosophical history, from the Middle Ages to the early modern period, leading humans to believe that absolute nothingness was impossible. The scientific revolution gradually changed this perception. Galileo, Descartes, Newton, and other thinkers began to regard space as a geometric stage, where forces and matter operate without needing to be fully filled. Newton, in particular, constructed a universe based on absolute space, where forces interact at a distance without requiring a material substrate. In contrast, Descartes emphasized that extension is an inherent property of matter. If space exists, something must occupy it. Gradually, the concept of vacuum became acceptable. Experiments by Pascal and Torricelli demonstrated that air has weight, and that a vacuum can exist as a physical entity. Yet deeper questions continued to haunt philosophy. What is absolute nothingness? Martin Heidegger, a 20th century German philosopher, brought this question back to the forefront when he asked, "Why is there something rather than nothing?" This is the ultimate question, one that cannot be answered through measurement or experiment, but only felt through meditation, experience, and contemplation. Heidegger argued that we are often too preoccupied with existence to notice its mystery, and that nothingness is not something to be explained, but something to be experienced. It reveals the fragility and wonder of being, reminding us that existence is not self-evident. In Heidegger's approach, nothingness is a haunting presence, a resonant silence after every thought, every breath, every star. When physics asks about the origin of the Big Bang, philosophy whispers about why there is everything at all. When scientists model the vacuum, philosophy questions what purpose that vacuum serves. This is a profound intersection between science and philosophy. Physics studies structure, philosophy studies meaning. And in this process, we realize that nothingness is not merely an emptiness, but the foundation that allows everything to exist. Human language also plays an important role in shaping the concept of nothingness. Words like darkness, cold, or nothing are expressions of absence, yet they exist through contrast with what is present. Cold tea is the absence of molecular energy. Darkness is the absence of light. Applied to the universe, the concept of nothingness is a lens, a mental tool to help us imagine a state where everything could fail to exist. Yet in physics, even the vacuum is never truly empty. It contains fluctuating fields, quantum foam, and countless latent possibilities. Absolute nothingness, in many modern physical theories, may be illogical, impossible. Existence seems embedded in the fabric of reality, even when we attempt to conceive complete absence. And here lies the crux. The human brain evolved in a world filled with objects, light, air, and survival drives. We think in opposites, presence and absence, light and dark, hot and cold. So, when imagining nothingness, we project familiar categories onto a domain where those rules may not exist. Modern physics shows that nothingness is not the default state. The default state is something, a sea of potential, an oscillating vacuum, a quantum foam. Only through the human mind, with its habit of opposites, can we imagine absolute nothingness. It is precisely this mental boundary that makes the journey into nothingness so wondrous. It is not merely a question of physics or philosophy, but an ongoing dialogue between perception, existence, and possibility. We realize that nothingness is not an enemy, not a terrifying void, but the silent foundation that allows everything to exist. And within that silence, we sense the fragility and wonder of being, our own existence, and the miraculous truth that anything could exist. As we begin to immerse ourselves in the idea that the universe does not require a beginning, a strange yet natural awareness begins to emerge, that everything could have always existed, even before stars, planets, or the very concept of time appeared. This challenges our biological instincts, which are accustomed to cycles of birth and death, with clear beginnings and endings. We are born, we live, we die, rivers flow and then run dry, fires blaze and then extinguish. From these observations, we naturally assume that the entire universe must also have begun at some point. But if existence is the default, then a beginning is merely an illusion, a projection of perception, not a condition of reality. An eternal universe requires no explosion, no starting point, and no first cause. It simply exists, gently yet immovably. In modern physics, this awareness is not entirely divorced from experiment. The concept of quantum foam suggests that even in the lowest energy state, space is not empty. It vibrates, bubbles, and contains the potential for the emergence of tiny universes. These bubbles do not exist in isolation. They continuously arise and vanish like waves on the ocean. And if we view the entire ocean of foam rather than the small universes themselves, we see a foundation that has always existed, an eternal presence requiring no beginning and never ending. Within this framework, the notion of absolute nothingness becomes irrational. No state of complete emptiness exists. Existence is not an exception, but a rule. From a philosophical perspective, this reverses the way we typically pose the question. It is no longer, how did the universe arise from nothing, but rather, why did we ever assume that nothingness was natural? The idea of an eternal universe does not diminish wonder. On the contrary, it highlights the continuity and limitless potential of reality. Every moment, every event, every atom arises not from nothing, but from a subtle foundation that always existed, a vibrating sea of potential that has never ceased. Ancient philosophers such as Heraclitus and Plato may not have envisioned all of this, yet they approached it spiritually. Heraclitus saw the continuous flow of the universe, light transforming like fire, while Plato sought eternal forms, immaterial archetypes. Aristotle, Plato's student, rejected the concept of nothingness, believing that every region of the universe must be filled with something. These notions, although dominant in the medieval period, left an important legacy: the awareness that nothingness and existence always exist in relation to each other, that to have something, we must acknowledge the not something, or at least imagine it. The 17th and 18th centuries marked the leap of modern science. Newton shaped the universe based on absolute space and gravity. Galileo pioneered experiment and observation. Pascal and Torricelli demonstrated that a vacuum can exist physically. Yet even in these experiments, the vacuum is not entirely empty. It is an oscillating domain where energy, fields, and virtual particles exist. Modern cosmology, from Einstein's relativity to quantum mechanics, continues to emphasize that even space and time are emergent phenomena, not absolute foundations. Space expands, time flows, particles appear and vanish, but the very potential for existence never disappears. In modern thought, perhaps the most important realization is that this eternal existence is not a rigid or meaningless abstraction. It is intuitive, close to human experience, like when we quietly gaze at the night sky, sensing its vast immensity without knowing where it began. Like when we hear waves crash upon the shore, realizing that this cycle has always existed before we arrived. Or when our mind touches the idea that everything could have always existed, not born from nothing, needing no cause, needing no time. In fact, this idea brings profound peace. It frees humans from the pressure of seeking a first cause or an ultimate origin. If the universe itself and the laws of physics have always been eternal, then every phenomenon, from the formation of galaxies to the life of a bird or the breath of a human, are merely passing expressions on a foundation that has always existed. And this awareness does not diminish wonder. On the contrary, it emphasizes continuity, infinite potential, and beauty in every appearing moment. We begin to understand that the universe may never have needed a beginning. No explosion is required, no collision. Instead, there is a continuous process, a flowing potential, where universes, galaxies, and life emerge in their own ways, from a foundation that has always existed, eternal and never completely silent. And in this awareness, nothingness becomes a concept dependent on human imagination, not something that can be truly observed or exist. It is strange yet serene, the idea that something has always existed, not born from nothing, requiring no cause, simply existing, offers a new perspective on the universe and ourselves. It reminds us that existence is the default, that nothingness is merely a product of imagination, and that every moment we live is part of an eternal flow, a sea of potential from which everything emerges. This is the philosophy of continuity, of potential, of a universe from which all possibilities arise, exist, and fade, while the foundation remains always present, silent, eternal, and infinite. The idea that our universe might be a simulation opens up a perspective that is at once familiar and strange. It is familiar because we live amid screens, algorithms, digitized models, and digital replicas of reality. We play games, create predictive models, draft architectural plans, and imagine virtual worlds that we control with a click or a swipe. But it is precisely this familiarity that makes the concept of a simulation startling when applied to the entire universe. If everything we see, the galaxies, the particles, the wind, the light of dawn, our thoughts and emotions, is merely the product of a vast computational system, then the way we understand nothingness, existence, and the nature of reality must be completely reshaped. In this model, the laws of physics are no longer the ultimate foundation of reality. They become basic code snippets, pre-programmed logical rules, algorithms through which everything manifests. Space, time, and energy are no longer fundamental entities, but only data structures, layers of display that we mistake for existence. As in a video game, an object that has not yet loaded still exists in potential, not in actuality, but ready to appear when needed. Similarly, in a simulated universe, every phenomenon may not be computed until an observation occurs, a quantum lazy load, where reality only unfolds when called upon, conserving energy while maintaining continuity. Yet, even when imagining nothingness within the framework of a simulation, we encounter a paradox. An empty drive, a file without data, or a screen that is off still exists in some way. It has electrons, circuits, memory cells, and basic structures that allow potential to occur. No absolute nothing exists. Nothingness, understood in the absolute sense, remains a concept created by perception. Within the simulation framework, nothingness is the absence of computation, but that absence itself relies on a foundation that allows emergence, a server not yet powered on, an abstract space where all possibilities can still occur. And if we go further, imagining that not only our universe, but all realities are an infinite chain of simulations, a vast digital matryoshka, then beginnings become even stranger. Each simulation could be built from a deeper simulation, and the entities within that simulation could themselves be simulated by higher level entities. There is no ultimate starting point. Everything is a recursive process, a chain of continuously self-generating layers of reality, always operating, always creating new realities, each obeying its own rules, but still embedded within a deeper logical framework. These reflections confront us with a profound philosophical question. If everything is just a simulation, what are we? Do we truly exist, or are we merely numbers, algorithms, data models appearing in a larger universe that we cannot see? Yet our existence, simulated or not, remains a vivid experience, full of color and emotion. Love, sorrow, the wonder of dawn, or curiosity about the stars do not lose value because they occur within the framework we call reality. In this context, nothingness is not a state but an unrealized potential, a void yet to be computed, and that potential is flexible, depth, infinite, and creative. This brings us back to a familiar insight of modern philosophy, that all existence depends on the rules and foundations that allow it to manifest. Whether we speak of quantum foam, quantum mechanics, or a digital simulation, the core is the same. There is a basis, a silent foundation that allows everything to happen. Even in the imagined space of nothingness, there is always a possibility, an anchor from which all realities can emerge. These reflections are not merely intellectual exercises. They genuinely open a new perspective on the relationship between humans and the universe. If everything can be simulated, then our consciousness, imagination, and sense of being become immensely valuable. They are the first experiences to arise, the code not yet computed, the moments that appear from the eternal foundation. Even if the simulation is artificial, we can still experience the universe with all its wonder and mystery. And thus, nothingness becomes a soft concept, no longer the absolute opposite of existence, but a state of potential, an opportunity for everything to appear. In a calculated world, nothingness is not absence, but the silence before the song, the pause before the melody, the potential for all miracles. We, whether human or data, live within that music, oscillating between reality and possibility, between what is and what is not, between life and conjecture. Therefore, when we close our eyes and imagine the universe, whether as quantum foam, a simulation server, or an unrendered reality, we are also confronting the same mystery. Existence does not require nothingness. Being does not require a beginning, and infinite potential is always present, gentle yet unshakable. We do not need to know whether we live in a simulation or in the base reality. What matters is that we are experiencing, observing, thinking, and feeling. And that experience at any level still brings wonder, the silent eternity, and the never-ending song of the universe. In the quiet of the night, when everything around sinks into stillness and only your own breath remains, a gentle yet powerful awareness gradually emerges that existence, whether fleeting or eternal, is not self-evident, but a small miracle unfolding in every moment. We are accustomed to living within repetitive rhythms, in mundane habits, and often forget that even a single moment of being is a gift granted by the universe itself. Questions about what happened before the universe, about the origin of all things, or about the nature of nothingness may seem distant, yet they guide us toward a deeper awareness that our existence is part of a vast web of connections with everything around us. When we place ourselves in the context of the universe, everything becomes relative. A towering volcano, a lazily flowing river, or a distant star blazing in the sky, all are pieces of the vast picture of which we are only a very small part. But it is precisely this smallness that makes us extraordinary. We have the capacity to perceive, observe, and reflect upon ourselves and the universe. The atoms that make up our bodies were once particles in ancient stars. The electrical impulses in our brains follow the same laws that govern galaxies. Seen this way, we are no longer separate from the universe, but a part of it. The universe reflecting upon itself through each thought, each action, each heartbeat. Human curiosity is proof of this. From the first campfires, we looked up at the sky, asking ourselves what happened before everything began. These questions are not meant to yield a definitive answer, but to remind us of our place in the vast flow of time and space. They help us momentarily step away from daily worries, from to-do lists to existential pressures, and direct our gaze outward beyond ourselves. For when faced with the universe, petty concerns become small, like ripples on the surface of an immense sea. Remarkably, questions about nothingness, beginnings, and the origins of all things bring humility and freedom. By acknowledging that we may never know what occurred before the universe, we also relinquish the need for absolute answers. This letting go does not weaken our capacity for thought or exploration. Rather, it opens a new space, a space for imagination, contemplation, and full awareness. We begin to love the questions themselves, to cherish uncertainty, and to see the beauty in infinite possibilities that have yet to be realized. From this perspective, nothingness is no longer an adversary of existence, but a state of potential. The pause between the songs of the universe, the silence waiting to be filled, is nothingness. It is not empty, but brimming with possibility. A moment yet to be experienced, an action yet to be taken, an idea yet to be formed, all contain vitality and potential. And in this awareness, we see that even absence is part of ongoing creation. The universe, in one way or another, is in constant motion, continuously evolving, and perpetually generating new opportunities for existence and experience. We, as conscious beings, are also invited to participate in this eternal flow. Our thoughts, our emotions, and each of our actions not only affect ourselves, but weave into the vast web connecting all things. A word, a small gesture, a quiet moment of observation can resonate far and wide, spreading like ripples across water, connecting us to a whole that we often do not perceive. Thus, reflecting on nothingness and beginnings is not meaningless. On the contrary, it helps us feel connected and more responsible to the present. This sense of wonder, curiosity, and contemplation also brings a kind of peace. When we acknowledge that the universe may have no beginning or end, that everything arises from potential and possibility, we see ourselves as part of a story much larger than ourselves. A story that judges nothing, hurries nothing, demands nothing. It only requires that we exist, perceive, and experience. This allows us to cherish each moment, each breath, each light of dawn, and every deep resonance within. Ultimately, the value of these questions lies not in finding the answers, but in how they transform us. They expand our vision, deepen our experience, and connect us to a greater consciousness. They remind us that we do not live solely for ourselves, but are part of the vast flow of the universe becoming self-aware through us. And that awareness, in the quiet moments of night, in the silent rhythm of nothingness, becomes a gentle, profound, and extraordinary song. A song of existence, of potential, and of the enduring connection between humanity and the cosmos. In that moment of stillness, when the mind begins to release everyday worries, we realize that silence, the state of not knowing, is itself a form of vibrant existence. Often we seek answers, solid truth to rely upon, but perhaps the most wonderful thing lies in not needing to know. For when we do not know, we are freer. Imagination expands, the capacity for contemplation is nurtured, and a sense of wonder becomes a normal part of life. Mystery is not an enemy, but a silent guide, reminding us that the journey of exploration, not the destination, is what truly matters. Looking deeper into the nature of nothingness, we see that it is not a cold void, but a realm of infinite potential. Nothingness, in this way, is like the silence between notes in a symphony. It is not complete absence, but a space where all possibilities may arise, where every beginning can be formed. If the universe is a piece of music, then nothingness is the space between sounds, creating resonance, allowing each note to rise and fall, ultimately forming a harmonious whole. And it is this emptiness, this state of not knowing, that gives us the capacity to perceive existence with full freshness. From this perspective, each of our small actions becomes extraordinary. A breath, a glance, a smile, a caring gesture, all are ways in which we participate in the flow of existence. We are not merely observers. We are agents, co-creators in a continuously changing universe. And it is the awareness of this creative potential that gives us a profound sense of meaning. There is no need to explain the universe or fully understand every law of physics. It is enough to recognize that each moment of existence is a miracle, and every experience, however small, contributes to the vast whole. Another remarkable aspect is that by accepting uncertainty, we also accept ourselves. We do not need to have all the answers, understand everything, or control every twist and turn of life. Acknowledging this limitation brings an unexpected kind of freedom. Freedom to breathe, to contemplate, to live unbound by the demand for absolute certainty. This is a freedom far deeper than any external power or achievement. It allows us to be more at peace in the flow of daily life, whether in work, personal worries, or complex relationships. And when we quietly observe the universe, whether through a telescope, scientific study, or simply by looking at the night sky, we realize that we share the same rhythm as everything around us. Even when stars burned billions of years ago, their light still reaches our eyes, reminding us that time and space are not rigid walls. They are flows, where past, present, and future intersect, where we can find a subtle connection with the entire cosmos. Each light is a story, each of our breaths a new chapter in that grand story, and every question about nothingness or beginnings is a reminder that we are part of the whole reflecting upon itself. Perhaps the most astonishing thing is not the answers to questions about the universe, but our capacity for self awareness. We, with all our fragility and finitude, can question the infinite and the eternal. We can ponder what cannot be seen, listen to what cannot be heard, and imagine what lies beyond sensory reach. This capacity not only sets us apart, it places us at the center of a profound experience of existence, where awareness and wonder become inseparable parts of life. This also reminds us that sometimes not knowing is a gift. In not knowing, we can still live fully, love fully, contemplate fully, and feel wonder. There is no need to decode every mystery, no need to grasp every law, only to walk, observe, and ask questions gently. For the wonder is not always in the answer, it lies in presence, in the subtle rhythm between being and non being, between existence and potential. And it is this rhythm that gives us a deep sense of comfort. When looking out at the night, hearing the rustle of wind or leaves, we can feel the subtle connection between ourselves and the universe. We see that there is no need for a specific beginning or a definite endpoint to recognize beauty. Each moment is a miracle, each experience a part of the eternal story we are fortunate to live. Within that uncertainty, within that unexplained void, we find freedom, wonder, and joy. We become beings capable of contemplation, capable of amazement, capable of loving the question itself, capable of immersing ourselves in infinite possibility. And in that silence, in the dim light of unrealized potential, we realize that nothingness, if it exists, is not fear or emptiness, but an open space allowing life, awareness, and wonder to exist fully. So, as gentle sleep begins to arrive, as the mind relaxes and the breath slows, we can take comfort in knowing that merely questioning, contemplating, and understanding the mysteries of the universe is enough to make for an extraordinary journey. Whether the ultimate answers exist or not, the act of inquiry transforms us into part of something greater than ourselves. And it is this, in the quiet and the gentle, that brings us the deepest beauty, a beauty unbroken by time or space, a beauty inherent in the fact that we are beings capable of wonder, awe, and contemplation.